A plus B. As my physics teacher used to say, head to tail, never fail. Sometimes I hear the gangsters. Folks, welcome to Vector Calculus. So you know how to add numbers. 2 plus 3, for example. All you have to do, take 2 of your fingers, take 3 of your fingers, add them, and you get 5. So adding integers is no problem. But what about vectors? How do you add 2 vectors? If I give you an arrow, if I give you this arrow, and I told you to add it up to this arrow, you would tell me I've gone insane. What do I mean when I say add this arrow, let's call this arrow A, to this arrow, let's call this arrow B? What does it mean to add 2 arrows? What does it mean to add 2 vectors? Well, you can use formulas, you can use tables, you can use memorization, but here we're going to use a hands-on way to approach vector addition. We're going to use barbecue grills. So here I've got 2 barbecue grill sticks, and each of these represent a vector. Now, if I give you one of these sticks right here, and another one of these sticks right here, and I ask you to add them up, what would you do? How would you add these 2 arrows up? Well, that's what we're going to answer today. Let's go ahead and take a look. What can we do? Let me show you some vectors, okay? This time it's going to be a bit easier. Here's my first vector, let's call it vector A, and here's my second vector. I'll draw it in vector right here, B. And now I want to find A plus B. How do I do that? Well, again, what I'm going to do is take my vector B, kind of slide it up. It's still going to be vector B, but all I'm doing is just sliding it up. And I slide up my vector B, and here it ends up. Okay, so it ends up there, but what does that mean? Well, the vector connecting the tail of vector A to the head of vector B is going to be A plus B. As my physics teacher used to say, head to tail, never fail. Sometimes I hear the gangsters saying that, but turns out as a vector calculus student, you'll also be learning to say that. A plus B, you're just going to add them up using head to tail. As you might remember, head to tail, never fail. You just add them up, very simple. Now, that's the geometric definition of vector addition, but what's the algebraic definition? Well, the algebraic definition doesn't tell you much, but it's actually very easy to comprehend, right? So my vector A comes with some numbers, right? It's kind of it's a vector. It has some x coordinate and some y coordinate. My vector B has some x coordinate and y coordinate. It has an x component and a y component. Okay, so let's say, I don't know, B is, it looks longer, so I'll just say 5 and 7. Now, if I add these 2 vectors up, I'm obviously going to get A plus B. And it's really as easy as you think it is. 2 plus 5 is going to give me 7. 3 plus 7 is going to give me 10. And this vector is going to be A plus B. This is going to be the resultant. And really, folks, that's as easy as it gets. This is vector addition. You add them up geometrically. It's the parallelogram method, head to tail, never fail. This is the algebraic way. We just add up their components, and that's all there is to it. Okay, so we have finally finished drawing the grid. Who likes this grid? Raise your hand. Raise your hand.
Very nice.
Wow, okay, so
you spent too much effort on it, but it looks horrible.
but I'm gonna call this the head, and this will be the tail of my vector. So let's go ahead and put our first vector down. That is the first vector on my coordinate plane. Where is my second vector going to be? My second vector is going to be somewhere here, like the second vector. And now I want to add these 2 vectors. So how's that going to work? I have 2 vectors and I want to add them. How is that going to work? So let's try to imagine it as, here's my first vector, here's my second vector. I want to add them up. So do we have any ideas how we can add up this vector? head and tail. So one thing we can do is move this vector, the tail of this vector, onto the head of the original vector. And what do you get if you do that? You get a certain type of shape. Let's see what kind of a shape we can make if we take this vector and kind of bring it over here, right? So if you take the same vector and bring it over there, what kind of shape do we get? Well, we're gonna get something like this. Bring it right over here, and you're gonna start noticing you get a parallelogram. To helping us add these two vectors. Here's one part of the parallelogram, but remember, here was our first vector. We can also bring it over here. And notice if you bring our first vector over here, what do you get? You also get a parallelogram, right? So here you've got the four sides of a parallelogram represented by our two vectors, right? Let's call it vector A. And we just moved it over here, shifted it onto the side, but it's still the same vector, it's still A. Likewise, we started with our orange vector, let's call it B. We just shifted it, right? We just brought it over. That's still vector B. And now to add vector A and B, here's the magic step. To add A and B, it's going to be one of the diagonals of this parallelogram. And as a matter of fact, which diagonals in a parallelogram, but you have to decide which diagonal, which one of the red diagonals is going to be A plus B. A plus B. So we're going to go from this tail of vector A to the head of vector B. And what sum is that going to give us? It's going to give us this vector right over here. Right over here, it's going to give us this diagonal, and that is going to be A plus B. Okay. A plus B is just going to be this diagonal of the parallelogram. Alright, folks, let's go ahead and take a look at yet another example of vector addition. Alright, folks, that's it for this lecture on vector calculus, and we'll check you out next time.